Ganyan talaga yung pangarap ko.
Uy, Jet! Uy, pasado kami. For the first time in forever, pasado kami, bro!
Pasado kami.
Wala. Bagsak ako.
Sa'yo. Alo! Wala, paano niya? Di ba ga-attend ka ng revision?
Oo, kailangan eh.
Okay lang yan. Ay, alam ko na! Hindi ko ba ito sa crush mo?
Ha? Ano? Hindi. Hindi ko nga nakakaya.
Pwede! Pwede!
Hehe.
Pwede! Paturo ka sa crush mo.
Uy! Si ano? Si crush mo?
해봐도 해 자꾸 티가 나나 봐 Beautiful, beautiful lady 봐도
Uy, kawan!
Uy! Uy! Ang tagal mo!
Sorry, may ginawa kami eh.
Ah, sige. Anong ginawa niyo?
Pascal.
Pascal? Ano yung naman project? Bagong project na yan?
Subject yun, sira!
Project nga! Ay! Wala.
Uy, tignan mo yun, oh. May nagkakaroon sa'yo.
Sira! Shumi ka!
Totoo naman, alam mo bang kalat? May gusto sa'yo. Oo!
Kalat, di ko alam. Hindi totoo yan.
Totoo yun. Ang dami kayo nagkakaroon sa'yo.
Wow, buti pa kayo. Alam mo, hindi.
Oh, ang isang katulad mo
Uy! Patulong ka na doon.
Mina, talaga?
Oo nga, pabebe ka.
Ayan na yung ano, oh.
This is the moment.
Yes!
Ano yun?
Magpapatunsan ako sa basic calculus.
Oo naman. Bukas, sige.
Uy! Oras na!
Oo nga, labasa na kami ah.
Bye!
Ganito kasi yun. So, according sa teacher ko,
So, para sa first example natin sa derivatives of trigonometric functions, our first problem it will be g of x is equal to secant x over the quantity of 2 sin x plus 1. So, para masolve natin yung equation, ang first na natin dapat na inalam natin is alamin natin what rules are needed to solve the equation. So, in this case, quotient rule ang kailangan natin gawin. Then, next step is we have to rewrite or we have to get the derivatives of the function according and rewrite it according to the quotient rule. So, g prime of x is equal to 2 sin x plus 1 multiplied by the quantity of secant x tangent x minus the quantity of secant x times 2 cosine x plus 1. Although, according to the rules of constant, 1 is a constant number, so it will be equal to 0. Over the quantity of 2 sin x plus 1 squared. Next step. So for our next step, we will apply the distribution method. So 2 sin x will be multiplied to the quantity of secant x and tangent x. And 1 will be multiplied by the quantity of secant x tangent x. Secant x will also be multiplied to the quantity of cosine x. So, our equation will then be the quantity of 2 sin x, secant x, tangent x, plus secant x tangent x minus the quantity of 2 cosine x secant x. It is important that we will need to put parentheses on every term applied. And then, let us bring down 2 sine x plus 1 squared. Let us recall the following terms. Secant x is equal to 1 over cosine x. Tangent x is equal to sine x over cosine x. Cosecant x is equal to 1 over sine x. And lastly, cotangent x is equal to 1 over tangent x. It is important that we have to memorize or remember these following terms. So, according to what we have recalled, we will substitute secant x to the quantity of 1 over cosine x. And since 2 sine x is equivalent to 2 sine x over 1, we simply have to multiply 2 sine x to the quantity of 1 at the numerator part, and cosine x will be multiplied to 1 at the denominator part of cosine x. Then, the other secant x will also be substituted by 1 over cosine x. Again, since 2 cosine x is equivalent to 2 cosine x over 1, we can simply cancel out both terms. So let us rewrite the equations. It will be 2 sine x multiplied by the quantity of 1 over cosine x plus the quantity of secant x tangent x minus 2 cosine x multiplied by the quantity of 1 over cosine x over the quantity of 2 sine x plus 1 squared. In this equation, we can simply cancel out cosine and the other cosine. And in this one, we can simply substitute or multiply sine x to the denominator of 1 over cosine x, and it will be 2 tangent x squared plus secant x tangent x minus 2 over 2 sine x plus 1 squared. That's our final answer. Second problem of the derivatives of trigonometric functions. Our next problem will be y is equal to tangent theta plus 3 cosecant theta. First, we have to observe what rules are applied. And in this equation, sum and difference rules were applied. So let's get the derivative. dy over dx is equal to secant squared theta plus 3 multiplied by the quantity of negative cosecant theta cotangent theta. Since 3 is positive and cosecant theta cotangent theta is negative, we simply multiply the signs. It will be secant squared theta minus 3 cosecant theta cotangent theta. That is our final answer. for our first problem of the inverse trigonometric functions, our equation will be y is equal to arc sine x minus arc cosine x. In order to solve this one, first we have to know what rules are applied. Again, this equation uses the sum and difference rule. So the derivative of dy over dx is equal to 1 over square root of 1 minus x squared minus the quantity of negative 1 square root of 1 minus x squared. Since negative 1 over square root of 1 minus x squared is negative, we simply multiply both sides. So it will be 1 over square root of 1 minus x squared plus the quantity of 1 over square root of 1 minus x squared. We simply add the two numerators. Then it will be 2 over square root of 1 minus x squared. That is our final answer. So for our second problem of the inverse trigonometric functions, our equation will be y is equal to arc secant x plus arc cosecant x. Again, this equation follows the sum and difference rule. So dy over dx, the derivative is equal to 1 over the magnitude of x multiplied by the quantity of x squared minus 1 plus the quantity of negative 1 over the magnitude of x multiplied by square root of x squared minus 1. So again, we simply multiply both signs, the positive and the negative sign. It will be 1 over the magnitude of x multiplied by square root of x squared minus 1 minus the quantity of 1 over magnitude of x multiplied by square root of x squared minus 1. We then simply subtract the two numerators present. It will be equal to 0. That's our final answer. So for our first problem of logarithmic functions, our first problem will be y is equal to ln x over x squared. So again, we observe that this equation follows quotient rule. Let us then rewrite the equation according to the quotient rule while getting the derivative at the exact time. So it will be dy over dx is equal to x squared multiplied by the quantity of 1 over x subtracted by ln x multiplied by 2x over x squared squared. So then, we can cancel out x squared to the other x. We can cancel out x squared to the other x. And then, we simply multiply 2 and 2. So then it will be x minus 2x ln x over x raised to 4. That's our final answer. For our second problem of logarithmic functions, our problem will be ln cosine multiplied by 2x plus 1. As we can observe, this equation follows chain rule. So we have to know what's our y and what's our u. Let y be ln u. And u is equal to cosine 2x plus 1. We get the derivative of y first. It will be dy over dx is equal to 1 over u multiplied by negative sign times 2x plus 1 multiplied by the derivative of 2x plus 1, it will be 2. Then, we rewrite the equation 1 over u is multiplied to negative sign times 2x plus 1. It will be 1 over cosine 2x plus 1 multiplied by negative 2 sine 2x plus 1. Then it will be equal to negative 2 sine 2x plus 1 over cosine multiplied by 2x plus 1. Since sine and cosine can also be called tangent, it will be negative 2 tangent multiplied by 2x plus 1. And that's our final